We looked at primary trig ratios. Did you guys look at secondary ones last year? Yeah. 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 They're fun. It's okay. You don't have to remember that. It was extra. But now it's not. So welcome. Okay. So we have to memorize our primary trig ratios, which are sine, cos, and tan. None of these were made up by me, but these are acronyms for it. Sign your resume, or for WOW, it's a resume. Sign your resume. And cook extra rice with an X, because it wouldn't make sense if it was spelled correctly, which that works well for you too. And then, since what he said yesterday, I'm just going based off of WOW, not because I've actually seen anything poorly done. And then tan your X box. He's the one who said he can't spell. I haven't seen, he doesn't write anything to me. I have no idea.
This looks perfect.
Yeah, see? Okay, so sign your resume, cook extra rice, and tan your Xbox, okay? Tanning your Xbox is weird. I don't know why you do it. It was an acronym. We use it. You're welcome. Okay, so the thing here to note is the reason why your unit circle, the reason why it's cos then sine. You know how I told you it's cos theta then sine theta on your unit circle? The reason why that is what is R on your unit circle? R is? Yes, and it is? 1. Yep, it's true. It's true. I always laugh when I ask a question expecting a certain answer and I don't get it. Because it's true. Not where I was going. So it's sine your resume, right? But your resume is actually a 1 on the unit circle. So sine theta on the unit circle is just y. Because you would just take the y and divide by 1, which is silly. So that's why the unit circle, the y value, is sine. Now, cos is cook extra rice. Well, rice is 1 on the unit circle. So it'd be x divided by 1, so it's just x. So that's why it can just be x. And then on the unit circle we have tan. Tan is y divided by x because there is no r on it, right? There's no r in it's tan your x box. It's tan is y over x. So if I want anything off the unit circle in tan form, I have to take the y and divide it by the x every single time. So your unit circle will actually give you all your trig ratios. It'll give you cos because it's x. It'll give you sine because it's y. It'll give you tan. You just have to do y divided by x off your unit circle. Okay? Now, there's the Calgary Stampede. Cos, it's y, sine. Cos is x, sine is y. Now we have the secondary trig ratios. The key way to remember this is that the c goes with the s and the s goes with the c. So cosecant goes with sine, and secant goes with cos, because c doesn't go with c and s doesn't go with s. And then cotangent goes with tan because it has tangent in it. That one's kind of a giveaway. If you forget, you have a formula sheet. It tells you. Okay, so we look at the top right of our formula sheet. And it says cosecant equals 1 over sine, correct? So if I want cosecant off the unit circle, what am I just going to do? I'm going to go 1 divided by the y on the unit circle, right? I'm going to do 1 divided by the y. 1 divided by anything, what does that do? What does 1 divided by anything do? It makes the reciprocal, doesn't it? So 1 divided by sine, if sine was a half, let's say, we'd do 1 divided by a half, so we get 1 divided by, or 1 times, 2 over 1, so it would be 2. So it's literally just the reciprocal. So, do I actually have to go 1 divided by y? No? Could I just take the y's and flip them? And tell me what it is? Yeah. So secant and cosecant are really easy actually as well off the unit circle, because cosecant goes with sine. So it's just y flipped. And secant goes with cos. So it's just cos flipped. Right? And then cotan is the opposite of tan. So instead of it being tan your x box, it's going to be cotan x box your, technically. It just flips. Those make no sense. I don't really care. They're just a flip of that. Because they're just the reciprocal trig identities. They're just the other ones flipped. Okay? I wouldn't go and find tan and then flip it and give me cotan. Because tan is y divided by x, right? So you can't pull it off the unit circle quickly. So I would do cotan as x divided by y. I wouldn't go find tan and then flip it. That's just extra work. I would go literally x divided by y. Okay? If you don't remember, great thing up here, cotan helps you out. At the very top of your formula sheet, It says cos divided by sine. What's cos on the unit circle? And what's sine? It literally tells you. The only trig ratios it doesn't give you is sine and cos. Sign your resume, cook extra rice, tan your Xbox, and then flip them for the reciprocal again. Okay? Let me go through CAST rule, which you talked about last year. So, with CAST, it goes C-A-S-T. That sounded like a Ford, 1912 car. Is that even real? I don't know. Is there cars in 1912? It sounds like it's horn. We're real retro. We're driving a 1912 car through the school. Okay, so CAST, C-A-S-T. So all of them are positive here, correct? Then last year we went sine is positive here. Whose sine's Bessie? Who goes with sine? Who's the flip of sine? Cosecant. So not only is sine positive here, cosecant is also positive here. Because cosecant is just sine flipped, isn't it? So if sine's positive, cosecant's going to be positive because it's just the flipped version of it. It's not going to change its sign, right? It just flips it. Okay? If tan is positive here, what else is positive here? Cotan. Because cotan is just tan flipped. So if tan is positive, cotan's going to be positive. It's just flipped version of it. And cos? What's positive with cos? Secant. And then everything. Everything's just positive there. Right? Okay. Here we go. Given the following points, so this can happen. This can happen on a test where I give you a coordinate. Okay? And it just says, given the following point on the terminal arm of some rotational angle, find the exact value for all 6 trig ratios and the rotational angle. Okay? Rotational angle is like your principal angle. How long it takes to rotate to get to it. Okay? So, if I give you a coordinate in trig, the very first thing you should do is sketch it. It's at -2, -6. Watch me, I'm crazy. -2, -6. Boom. Elementary taught me so much. Junior high. I don't know. When do you start plotting points? Junior high? Yeah, kindergarten. They're going crazy. They learn their alphabets and plotting points at the same time. That's the new curriculum. That was a joke. It's just because it's crazy. All right. The new curriculum is hardcore.
Grade 6 social curriculum?
I don't know. The math is intense in some places, and then some places it's not. So. Well, you know what? You still do addition in grade 12, so that's good. I'm glad that he's still there. I'm glad they're doing that. I'm glad they're doing that.
I used to raise my teacher. I did win.
Okay. We need to get trig ratios. We agree?
Yes, I did. Yeah.
Okay. So, when I talked about rotational angles, the rotational angle we're going to do absolutely last. The rotational angle is going to be done last, but it's going to be this. So we know that the answer for our rotational angle should be between 100, we're going to do degrees, 180 and 270, should it not? Yes. Because it falls in between there. We agree? Okay. We know that at the very least we're going to have a rotational angle between 180 and 270, or if they ask for it in radians, it'd be between pi and 3 pi over 2. Okay? That we know. But we have to get the 3 trig ratios first. And by 3 I mean 6, because we're in grade 12. 6 trig ratios first, okay? Now, if we're asked for the 6 trig ratios, sign your Xbox. That is not true. Someone did that last year and has it stuck in my head now. Sign your resume. They'd be like, it's Xbox. No. Don't sign your Xbox. That's weird. You can't resell it. Sign your resume. Then cook extra rice. Tan your Xbox. And then we have to do the other one. So what letters do we need? We need X. We need Y. We need R. When we have a coordinate, what do we have? X and Y. So we can get tan and cotan very quickly, correct? But we first need to find R. Well, we always do bow ties. Remember how we did bow tie angles to reference angle? We're going to do bow tie too. We always go towards the x-axis. So it's going to be like this. Do you see that? So I can take this triangle out if I want to. This is the triangle, correct? Okay. It's actually a radius here, isn't it? Like I could keep going around and this would make a radius. Yeah? So my x is what? -2. My y is -6. So on here, I don't have to pull the triangle off. I'm just pulling it off so you can see that that's what this is. It's just a little triangle in here. Do you see that? So this is -2. This is -6. And now I need to find r. The thing with x is x can be negative or positive. We agree?
Yes.
Y can be negative or positive, depending on where it's drawn. But r is a radius, which is a length measure. Can it be negative? No. So the radius is always positive. Okay? R is always positive. So how do we find a third side when this is a 90? Pythagorean theorem. Yeah. So we do r squared equals -6 squared plus -2 squared. So r squared equals 36 plus 4, which is 40. Square root. When you take the square root, you take plus or minus always. The catch with this one is it's positive. Root 40 breaks down into what and what? 4 and 10. 4 comes out as a. So r actually equals 2 root 10. Positive 2 root 10. Yeah. Now we have to do the 6 trig ratios. Okay, just be appreciative that it's not too bad, okay? So we're going to do sine. Sine, now look, sine should always have a what beside it? A theta or an angle. Like if they give you an angle, the angle goes there. If they don't give you an angle, theta goes here. If not, it's sin. It's the word sin. It is not sine. They're very different. Okay? So, we don't want a sin, we want a sine. So we're going to go sine of theta. We always have to put a theta beside it or it is not sine, it is the word sin, and then you should write more of a sentence about that. I don't know. It wouldn't be good. I don't want that. So sine is sine what? Your resume. I thought you were going to go with resume personally. So sine your is what? Okay, so I have y equals -6. I have x equals -2, and I have r equals 2 root 10. So it's sine your resume, root 10. What's the problem? Grade 11 taught us this. You can't have a root 10 on the bottom. You need to rationalize the denominator, which means you have to multiply by root 10. So we're going to get -6 root 10 over, what's root 10 times root 10? 10. Because root 10 times root 10 is root 100, which is 10. When you multiply two roots together that are the same, you actually just get the number without the root. So we're going to get 2 times 10, which is 20, and then we can reduce. We can take a 2 out of both, so we'll get -3 root 10 over 10. So that's sine. Now we have cos. Cos theta equals, cook extra rice, -2 over 2 root 10. Extra rice. Now what am I going to multiply by? Root 10. So I get -2 root 10 over 2 times, root 10 times root 10 is 10, so 2 times 10, which is 20, and then I can take a 2 out of here, so I'm left with -1, a 2 out of here, so I'm left with 10, so it's root 10 over 10. Then tan. For these ones, tan and cotan are awesome, because unless they give you one with a square root, you just have numbers. Yeah?
Would it be negative?
Yep. So tan your x box. Your is -6. X box is -2, so we get 3. Cotan is x box your. So it's -2 over -6, which is a third. Or I could have just taken the answer 3 and done the reciprocal of it, right? Because cotan is just the reciprocal of tan. By sine, what goes with sine? Cosecant. Cosecant. And so if it's sine your resume, cosecant is resume your. So I get 2 root 10 over negative 6, which reduces to root 10 over negative 3, which sometimes they'll write as negative root 10 over 3, right? Because you can move that negative sign anywhere. It just can only exist in one spot. So it can be in the top, it can be out front, in front of the fraction, or it can be in the denominator. They can move it, right? As long as you have one negative sign. Then what's friends with cos? Secant. Just R is 2 root 10. This is sine your resume, so this is resume your, right? It's just the flip of it. So if this one is cook extra rice, then secant is rice extra. So 2 root 10 over negative 2, bless you. So they'll just bring the negative up and write it as negative root 10. If you flipped this, you'd have to rationalize again. So it'll end up being that. So you already rationalized it. No, I see if you look here, this is negative 6 over 2 root 10. Then I'd have to rationalize it. Then I do this, then I get this. I'm not taking this answer and just flipping it and then doing the rationalizing. Okay. I started right off the beginning because right off the beginning, the root would have been on the top. If I flip it now, I'm going to have to rationalize again, which I could have done. I could have taken negative 3 root 10 over 10 and flipped it and then rationalized the root 10 and reduced it. I'll still get root 10 over negative 3. Okay. Yeah. Either way works. So you can either go right off and say, sine is your resume, this is resume your, and start over, or you can take this answer, flip it, and then rationalize it. You'll still get the same answer. Now, we need to get the rotational angle. Now, let's think about this. If we do, where are all of the angles positive? In quadrant 1, correct? In the 1. In quadrant 1, they're all positive. We agree? And the reference angle is equal to the actual angle also in what quadrant? 1. We agree? Reference angle is equal to the angle, and we have it. If I had the reference angle, I would have this little piece here. I'm going to make it green. If I had the reference angle, I would have this little piece here, correct? And then I could just go 180 plus the reference angle, and boom, I'd have my answer, wouldn't I? So if I had my reference angle, I could add it to 180, boom, I have my rotational angle, I'm done. We agree? So how do I get my reference angle? My reference angle is always the same in quadrant 1, correct? All angles are positive in quadrant 1, we agree? So I can actually take any of these 6 trig ratios, and I can find the inverse of their angle, or the inverse of their fraction, and get an angle, right? Whenever you do inverse cos, inverse sine, inverse tan, you're getting an angle, right? You were taught that in grade 10. If you were ever looking for an angle on a triangle, remember you'd always have to go second sine, second cos, or second tan to get an angle. We agree? So I want an angle. I want a reference angle. If I want a reference angle, I have to take the positive of anything. So I actually, if I have a choice, I'm picking the positive version. And I'm picking the easiest one. And to me, that's tan. Now, you could pick cosecant or secant, but do you have a button for that? Do you have a button for cotan? No, those are harder, correct? So I'm going to pick one of the primary trig ratios to find the reference angle, either sine, cos, or tan. And to me, tan looks the nicest, because tan theta equals 3 is its answer, correct? So I have tan theta equals 3. Even if it equals negative 3, to get the reference angle, you always take the positive, because then it'll land it in quadrant 1. So even if this was tan of negative 3, I would do it as tan of 3. Because to get the reference angle, you want to land it in quadrant 1. So you always want the answer to be positive, right? So even if this was tan theta equals negative 3, I would take tan theta equals 3 to get the reference angle. Reference angle, not the real angle, the reference angle. So how do I get theta by itself? Because that's what I need. I need the angle. Tan neg 1 will cancel off a tan, right? What you do to one side, you do to the other. So I'm going to get theta equals tan neg 1 of 3. My answer is in degrees. So what do you need? I'm going to press second tan. Slap my hand and be like, what mode do I need to be in? Degrees. So go to your calculator, bless you. Make sure the mode you're in is degrees. Second tan 3, bless you. What do you get when you go second tan 3? 72.6? 71.6? That's my reference angle, correct? That's not the actual angle that a rotational angle. That's the reference angle. If I do second tan of any answer positive, I will get the reference angle every single time. So now I have the reference angle. This right here, this little green spot here is 71.6 degrees. So how am I going to get the rotational angle? Yeah. I'm going to go theta equals 180 degrees plus 71.6, because that's what I do when my angle is in quadrant 3. When my angle is in quadrant 3, I take the x-axis and I add 71.6. And what do I get? Does that make sense where it's drawn and where it's landing? Yeah. Seems realistic, doesn't it? Okay. Next one. Number 2, you try it out. Draw it out.
Can you use anything there?
Yep. Yep. Because you could put more than one coordinate on a Cartesian plane, right? So then you'd want to label them like A, B, C or something like that. So you try 3 and negative 4. 3 and negative 4 is awesome. Because 3 and negative 4 will always get you 5 as your radius, so you're not going to have to rationalize anything. Try it out. So this one we would draw first. So we have 1, 2, 3, 1, 2, 3, 4. So I know that that's my triangle. I know that this is my rotational angle. Correct? When I look at the triangle, I have x equals 3. I have y equals negative 4, and then I would go r squared equals negative 4 squared plus 3 squared, which is 25. So r equals plus or minus root 25, but it's r, so r equals 5. They use 3, 4, 5 a lot, which is nice. When I see that, it's like exciting because you don't have to rationalize anything, right? So if we do sine, make sure what's beside it. Theta, it's either has to have an angle beside it or a theta symbol, right? It can't just be the word sine. I see sine and then equals in the fraction. That's not true. Sin doesn't equal negative 4 over 5. Sin is like a definition of someone doing a wrongdoing, and like there should be like a sentence behind it, right? If you're using just sin without the theta. Okay, so sine theta equals sign your resume. Boom. Greatest day ever. Done. Cos theta. Cook extra rice. 3 over 5. Tan your Xbox. And then it's besties. Sine is besties with cosecant. So if it's sine your resume, this is resume your. Sine goes, or secant goes with cos. So if it's cook extra rice, it's rice extra. And then tan your Xbox, it's Xbox your. Right? Now you can take any of them. I would pick sine, cos, or tan. And if it's my choice, I would pick cos, because cos is positive. However, if I picked sine or I picked tan, you would just take the positive of them, right? It doesn't matter if you chose them. Does that make sense? You have to take the positives of them. If you take the negatives, you're going to find an angle that does not fall between 0 and 90. Okay? It'll be a negative angle, or it might not even fall between 0 and 90 at all, negative something else. Okay? So we're always going to do, for the reference angle, I'm going to do cos theta, but if I don't have a choice, I could do tan, but I'm going to do tan theta of 4/3, or sine theta of 4/5, positive, right? Because I want it to land between 0 and 90. So I'm going to take the positive of it, even if it is negative. So cos theta equals 3/5, and I'll prove that to you. So I'm going to go cos neg 1 of both sides, and I get theta equals cos neg 1 of 3/5. And what do we get for theta? Okay, I'm going to prove a point. If I go tan theta equals 4/3, and I go tan neg 1, theta is going to still equal 53.1 degrees. It's going to be the exact same. And if I did sine neg 1 of 4/5, it's going to get me 53.1 degrees. All of them. Okay? So this angle here is 53.1 because it's the reference angle. So how do I actually get the rotational angle? (360 degrees minus when it's in quadrant 4, I take 360 minus the reference angle every single time. 53.1 degrees, and what do I get? Does it make sense where it's drawn? Yeah? Looks good to me. Okay, we are skipping example 2. We're coming back to that tomorrow. We're going to carry on with using trig ratios, using trig ratios, using trig ratios. So I could give you a coordinate and ask for the 6 trig ratios and rotational angle, or I could just ask you for, go here, after this example 2, right here, example 3. I could ask you to just determine the exact value. Now, we've talked about some of these before. Yeah?
Why do you need to find all 6 ratio names?
Just practice. They'll usually ask for 1.
Okay.
And then they'll usually ask for the one that makes you have to rationalize the denominator. Kind, right? Okay, so example 3, determine the exact value. So what we're going to look at here is we've done sine, cos, and tan already, correct? We're going to now add secant, cosecant, and cotan. Actually, we can just done sine and cos, but that's okay. So we're going to go tan pi over 2. What the heck is tan pi over 2? Pi over 2 is at 90. Remember, radians to degrees, pi on bottom, correct? So you would literally just go pi over 2 times 180 over pi if you wanted to convert it to a degree. So just to make our brains helpful, we can go tan of 90, or you can get just really good at radians and know that that's at the top, right? It's the same thing. They are the same. We agree? Okay, tan of 90. Tan what? Tan your x box, correct? Tan is also sine over cos. If we forget, it's on our formula sheet. Okay, so tan your x box. What's your? 1. What's your x box? 0. What happens when we have a 0 in our denominator? Things explode. World's done. Or you say undefined. What actually happens is that whenever you divide by 0, we get a what? Rhymes with asymptote. We get an asymptote. Yes, we do. Good job. Very good. So on the tan graph, at 90 degrees on the tan graph, there's actually a vertical asymptote. Wowee is right. Okay. Cosecant. What's cosecant? Besties with sine. So if sine is sine your resume, cosecant is resume your. So I'm going to help myself out and be like, resume your, resume your. Okay. Now I need to know what the heck 7 pi over 6 is. So you can convert it if you want, or you can try and see if it's on there, which it is. When it's over 6, it's a 30-degree reference angle. 7 pi over 6 is the same as 210. So cosecant of 210. So we can do resume your, which would be 1 over y. But what do we do when it's 1 over y? What's that the same as? Y flipped, right? So what is y at 210? So it's technically negative. It's 1 over negative 1/2. Why is it a 1? The radius is 1. So it's literally just a flip of it. So what is it? Negative 2. Yeah. It'd be 1 divided by negative 1/2, which is 1 times negative 2 over 1.
Can we leave it as like in radians if we want to?
It just takes the fraction and flips it. So if it's negative 1/2, it's going to be negative 2 over 1. You just take your fraction and flip it. That's all 1 over something does. So whenever you have 1 over something, you take that fraction, flip it. Take that fraction, flip it. That's it. So sine of negative 300 is negative 300 on my unit circle. No, but its best friend coterminal angle 60 is. So how do we figure that out? We do negative 300. We can add 360 to it, and we get 60. This is the reason why coterminal angles are taught the very first. Because they'll get you back onto that unit circle where all the answers are, right? So this is the same as saying sine, this is equal to sine of 60 actually. Why? Because they terminate on the same arm, correct?
Just leave it at negative 300.
Yeah.
Yes, you can.
Connor's just making sure you're cool. But yeah, you don't have to write the 60. I just write it to prove that it's the exact same thing. Yeah. And sine at 60 is?
3 over 2.
Done. The hardest part about these is literally getting what the angle is on the unit circle, right? Okay. Secant of 60. Secant is best friends with who? Cos. Cook extra rice. So this one's going to be rice extra. So secant 60 is the same as 1 over whatever the heck x is there. What's x there? 1/2. So what happens when you do 1 over something? It just flips. So instead of it being half, it's 2 over 1, which is 2. Okay? Cos 150. This one you'll throw a party because it's just whatever the heck x is. What's cos 150? Root 3 over 2. Now some people might say, but it's x over r. What's r? 1. So that's why it doesn't, you don't have to write it, right? What about, Yep. It is negative. Sine 315. Go to 315. It's a 45, so it's going to be root 2 over 2, and it's sine, which is y, so it's negative. Yeah. Sine of negative 30. What's its best friend? 330. Because we can go negative 30 degrees plus 360 gives me 330. So this is the same as sine 330. They're not having nearly the fun you guys are. No. Don't let that screaming and excitement make you feel like they're having more fun. They're not. Okay, sine of 330 is negative 1/2. Okay, you guys are going to try h. Look at all these. Great times. Now, what happens when there's a squared in here? This cos squared, 225. Nope. You just find cos 225 and square it. This is equal to bracket cos 225 squared. So you just find cos 225, take that answer and square it. That's all you do. So you tried these ones out. Tan of 240. Tan your Xbox. What's your at 240? What's what? Negative root 3 over 2. And then I can stack fractions. Do I ever stack fractions? No. You will never, ever, 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 ever stack a fraction. If you're starting to stack a fraction, stop yourself and be like, write these out sideways. because they're impossible if I stack them. So I'm going to go root 3 over 2 divided by a half. Now, why wouldn't I stack them? Because fractions, you divide and multiply, and you flip and multiply what you're doing. So you're going to go negative root 3 over 2 times 2 over 1, and then these will cancel, and I just get negative root 3. And also, just so you know, all 60-degree reference angles on tan will be a negative root 3s, or root 3s. Yeah? Are they backwards? It would be positive. Messy. It's in quadrant 3. Tan 480, does it land on there? No, but its best friend 120 does. Yeah. So it's besties with tan 120. What's y at 120? Because it's your xbox. Y at 120 is root 3 over 2, and x is negative a half. So I'm going to get root 3 over 2 times negative 2 over 1. And I get negative root 3. Do you see this is another 60-degree reference angle? 120 is 60 away from 180, right? All tan 60-degree reference angles, we're going to get you root 3s, positives or negatives. Cos 225. What the heck is cos 225? Negative root 2 over 2, and I'm going to square it. What happens when I square a negative? Positive. What happens when I square a square root?
Just
2. What happens when I square 2? So what's my answer? 1/2. There's going to be questions in your textbook where you're going to have to like add cos 225 to sine 120. So you just have to find cos 225, sine 120, and then you have to add them like fractions, right? Common denominators. So that's going to be one question in your textbook. Okay? Let's look at one like this. What if I do cos of negative 5 pi over 2? Or negative 5 pi over 3. I have to find its coterminal. So I go negative 5 pi over 3, and I add 2 pi, which is adding 6 pi over 3. So I actually get pi over 3. So its best friend, pi over 3, is on. What is x at pi over 3? Yeah, I don't know what's happening. Survival. Okay, I could go through hundreds and hundreds more, but I'd rather you just practice them yourself and get started on your homework. So page 201, numbers 1 is like this. Number 5 is like the first question we did with the coordinate. And number 9 is the question that I was talking about where they'll ask you to do like sine 225 plus cos 120 or something like that. Okay? Try those.